Welcome to The Explainer. Today, we're going to track a microscopic parasite that has a massive, and I mean massive, global impact. We're about to follow its journey inside the human body to really understand a disease called schistosomiasis. And trust me, the twists and turns this parasite's life cycle takes are just unbelievable.
So to really get a sense of just how big this problem is, let's start with a number. 250 million. That's how many people are infected right now. That's more than the entire population of Brazil. It's a staggering figure, but believe it or not, it's really just the beginning of the story.
So that's the big question, right? How can a tiny creature, barely a centimeter long, cause a global health crisis on this kind of scale? Well, to answer that, we have to follow this parasite on its incredible and, frankly, terrifying journey.
Okay, so our story doesn't actually start in a person. It begins in fresh water. You can think of this as the parasite's staging ground, where it's just waiting for its chance to launch an invasion.
That's right. For us humans, getting infected can start with something as simple as touching contaminated water. These microscopic larvae, they're called cercariae, are just swimming around freely. And when they bump into human skin, they launch what is basically a microscopic amphibious assault.
So the first clue that you've been invaded is often this temporary, really itchy rash that people call swimmer's itch. And this isn't some typical allergic reaction. No, this is the feeling of direct physical damage as these cercaria literally burrow into your skin, using enzymes and other toxins to dissolve a path right through you.
And this, right here, this is the parasite's genius survival strategy, a really complex two-host life cycle. So after they get through your skin, the larvae ride your bloodstream, growing up into adult worms that can live for years inside your body. Then they lay thousands upon thousands of eggs. Those eggs have to get out, and if they make it into fresh water, they hatch and infect a very specific kind of snail. Inside that snail, they multiply like crazy, and boom, a whole new generation of cercaria is released, ready to find another person. This cycle is the engine driving the entire epidemic.
So, once they're inside, the adult worms get comfortable, and this is where the real battle begins. The initial invasion might be over, but a long, destructive war is about to be waged inside the body. Now, you'd think the main problem would be the adult worms, right? I mean, they're the invaders, and they can live for your entire life. But here's the twist. They aren't actually what causes the most severe symptoms of the disease.
The real pathogenesis, that's the process of how the disease actually develops, it comes from the body's own catastrophic immune response to the tens of thousands of eggs these worms are churning out every single day. See, a lot of those eggs don't make it out of the body. They get swept away in the bloodstream and end up trapped in our tissues. And this is absolutely the key takeaway. The disease is essentially a form of biological friendly fire. Your own immune system spots these trapped eggs, sees them as a major threat, and launches an all-out war. This creates these intense inflammatory masses called granulomas around the eggs, and it's this defensive reaction that causes immense collateral damage to your own organ.
And the impact of that friendly fire is, well, it's devastating. Depending on where the eggs get stuck, this immune response can cause terrible scarring in the liver. In the bladder, it can cause chronic lesions and is even linked to bladder cancer. In the intestines, it can lead to life-threatening dysentery. The eggs can even get swept up to the heart, the lungs, or, terrifyingly, the brain, causing absolute catastrophic failure.
Okay, so with all these different and severe symptoms, how in the world did doctors figure out what's going on? How did they identify the tiny culprit that's causing all of this damage?
Well, the diagnosis is confirmed by doing something that sounds almost too simple. You just have to look for the eggs. A clinician takes a stool or urine sample, puts it under a microscope, and if they find schistosoma eggs, that is the definitive proof of infection.
This slide is basically a detective's guide to the parasite. Each of the three main species leaves its own unique calling card. S. hematobium eggs, which you find in urine, have this really distinct spine at one end. S. mansoni eggs, found in feces, have a sharp spine sticking out the side. And S. japonicum eggs, also in feces, are more rounded, with a spine that's way harder to see. These little differences are everything. They let doctors pinpoint the exact culprit and know what kind of damage to expect. So understanding this whole crazy life cycle isn't just a fascinating biology puzzle, it is literally the key to stopping this parasite in its tracks. Let's look at how all this knowledge gets turned into a public health strategy. Because there's no vaccine, you have to get creative and break this chain of infection. The approach has to hit the life cycle from multiple angles.
First, you treat infected people to stop them from passing on the eggs. Then, you improve sanitation so the eggs can't get into the water in the first place. Third, you control the snail population to get rid of that essential middleman. And finally, you educate communities so people can avoid getting infected to begin with.
Now, we do have a really effective drug called praziquantel that kills the adult worms. It's an amazing tool. But, and this is a huge but, treatment alone is like mopping up a flooded floor while the faucet is still running full blast. The only way to solve this problem for good is prevention, stopping that life cycle dead in its tracks.
And the scale of that challenge, well, it's massive. Remember that 250 million number? That's who's infected now. But get this, 600 million people, that's nearly twice the population of the United States, are currently at risk. They live in places where this parasite and its snail host are a constant threat. So that leaves us here with a final huge question. We understand the parasite's incredible journey. We know the devastating pathogenesis it causes through our own immune systems, and we have a clear 4-point plan to break its life cycle. The science is all there. The challenge now is putting it into practice on a global scale to finally bring this parasite's journey to an end, for good.